Okay, folks, so today we're going to look at Chapter 4. Chapter 4, we're going to take a look at price controls. And those price controls are initiated by the government. And price controls basically are trying to change the price of a product, making it higher or lower than the equilibrium price would be. So in a free market place, the price will settle at equilibrium. So here's price, quantity, supply of a product, demand of a product, and the price will settle here. And the quantity sold in the market is going to be this quantity here, where quantity supplied is the same as quantity demanded. So that's why the equilibrium price ends up here, because we have no surpluses, we have no shortages, so there's no pressure on the price to move up or down. So at equilibrium price, quantity supplied equals quantity demanded. However, sometimes the government decides that this price is not the desired price. It's not what it should be. And either they want the price higher than the equilibrium, or they want the price lower than the equilibrium price. Well, if they want to increase the price, what they can do is the government will impose a price control. And in this case, since we don't want the price to go below this price, so normally the price would settle here at equilibrium, but the government wants to settle it a little bit higher, or higher, not a little bit. That means that they're going to impose a price floor. In other words, folks, you cannot go, and I'm tapping on the floor, you cannot go below this floor. So this represents a floor. So the price is going to stop here. The price cannot go below this price. So normally the price would settle here, but with government control, here where we have a price floor, the price will settle here. So we have a price floor. And the best example that I can think of a price floor is minimum wage. Minimum wage is nothing but a price floor. So the government decides, well, in a free market, the prevailing wage for, let's say, unskilled labor would be a little bit too low. So let's make it higher. So let's say it would settle at $7 an hour. And the government comes in, $7 an hour is too low. Let's make it $12 an hour. Okay, that's the minimum that the price can go. That's the minimum that the wage can go. So minimum wage. Okay, but you can see what happens now with this price floor. Quantity demanded is going to be this quantity here, and quantity supplied is going to be this quantity here. So this is going to lead to a surplus. So we no longer going to have quantity supplied equals quantity demanded. If the price floor is high, then you're going to end up with a surplus. At that price, firms may be willing to produce more, and consumers would be willing to demand less. Quantity demand is lower than quantity supplied. In the case of labor, it could be that more people are willing to work if the wage is, let's say, $25 an hour. That's going to attract more people to come into the workforce, but at the same time, firms are willing to hire fewer people. So it's going to create a surplus of labor, if you will. Okay, now let's take a look at the opposite case where the government decides that this price is too high. So the equilibrium price is too high, and they want to settle the price lower than the equilibrium price. Well, in that case, what they're going to do is they're going to settle, they're going to put in a price ceiling. and it's a ceiling because you cannot go above it. So that's the maximum that can be charged for whatever product we're talking about. So a price ceiling stops the price from going over here at equilibrium. It stops it here. That's the maximum that can be charged. And an example of a price ceiling might be something like rent control. Okay, rent control stops the rent from going to the equilibrium, and it stops it below the equilibrium. But as you can see, if you have a price ceiling, that is going to lead to a shortage because quantity demanded is going to be high and quantity supplied is going to be lower. And this amount by which quantity demanded exceeds quantity supplied is the shortage. In general, those price controls are not really favored by economists. And somebody may say, but wait a second, because those price controls seem to be helping people that are in need of help. Okay, rent control or minimum wage. So they are helping some people. Well, don't economists want to help people? And the answer, of course they do. But they don't want to do it in a way that distorts the market. Okay, because either a price floor or a price ceiling is going to lead to a surplus or a shortage, so it doesn't make the market as efficient as it would otherwise be. So what would an economist say if they want to help people? And economists would say, well, if you want to help somebody, just give them money, but don't go into a market and distort that market in order for you to help a group of people. If you want to help a group of people, just give them money and leave the market alone. All right, folks. At this point, any questions on price ceilings or price floors? So please make sure that you understand, because you may see questions on a test like this, tricky questions. Maybe I put in a tricky question and I say, here. Whoops. Jack, can you mute yourself, please?
Yeah, sorry.
That's okay. So price, quantity, here's the supply of tomatoes, here's the demand for tomatoes, and let's say the price of tomatoes, the equilibrium price of tomatoes is $5 per pound. And at $5 per pound, there are 1 million tomatoes sold in the market, 1 million pounds of tomatoes. And then I say to you, the government comes in and imposes a price floor of $2 a pound. And then I ask you, since we have this government floor of $2 a pound, and at $2 a pound here, the quantity is 0.5 million, quantity supply, quantity demanded is 2 million. What is going to be the equilibrium price of tomatoes? And I'm asking you, any ideas what is going to be the equilibrium price of tomatoes and how many tomatoes will there be sold in the market? Now, remember I said it's a tricky question. Why is it a tricky question? Why? Because this is a price floor and the floor has to go above the equilibrium to have an impact. Here, what is going on is the tomatoes are sold in the market for $5 a pound. Everybody's selling the tomatoes at $5 a pound. And then the government comes in and says, you cannot sell your tomatoes for less than $2. No impact whatsoever. Nobody's selling tomatoes for less than $2. All the tomatoes are being sold for $5. So if the government imposes a price floor in the wrong place, it's not going to have any impact on the market. Okay, so the equilibrium price will still be $5 per pound, and 1 million tomatoes will be sold. Okay, no impact whatsoever. So for the price floor to have an impact, has to go above the equilibrium. So it has to go here. And the government says you cannot sell your tomatoes for less than $10 a pound. Well, guess what? Quantity demanded is going to be this quantity here. Quantity supplied is going to be this quantity here. So people only want to buy 500,000 tomatoes, and firms are willing to supply 2 million tomatoes. Well, how many tomatoes will there be sold now? Well, 500,000, because we only want to buy 500,000 tomatoes. So now, with the price floor above the equilibrium, it impacted the market. So you got to put the price floor above the equilibrium price and the price ceiling below the equilibrium price. If you put them in the wrong place, you're not going to have any impact on the market. And obviously, the goal of the government was to impact the market. So the ceiling always goes below and the floor goes above to have an impact on the market. Okay. Questions at this time? Okay, seems like no questions. So we can move on. So what I'm moving on now onto is what happens when there are changes in supply and changes in demand, because prices in real life, prices move because supply changes and demand changes. So let's take a look at what happens when there are changes in supply or changes in demand. And then later we're going to do changes in supply and demand at the same time. So first we only going to change demand or supply. Well, how many variations can we have? Well, here's the number of variations that we can have. We can have supply going up and demand staying the same. We can have supply going down and demand staying the same. We can have supply staying the same, demand going up. And obviously the last one, supply staying the same and demand going down. You can do those problems in your head, but if you want to take absolutely no chances, then it's much easier just with a graph. So if you have a problem where, let's say you have a question on a test where it says, suddenly there's an increase in the demand for strawberries. What do you think is going to happen to the equilibrium price and quantity for strawberries? Certainly, we can think about it logically and say, well, if suddenly everybody wants to buy strawberries, I would expect the price of strawberries to go up. And if everybody wants to buy strawberries, I would expect that more strawberries will be consumed in the market. So price goes up, quantity goes up. Certainly you can do it that way, thinking about it in a logical way. But if you don't want to take any chances whatsoever, then just do a graph. So you're going to start out with the regular supply and demand for strawberries. So here's price, here's quantity, here's the supply, and here's the demand for strawberries. And we're starting out with this equilibrium price and this equilibrium quantity. And then what we said was that the demand for strawberry increases. Well, that means that I'm going to have to shift the demand for strawberries to the right, because that shows an increase in demand. And when I shift the demand for strawberry to the right, from D to D prime, the new equilibrium price and quantity will be here at the intersection of D prime and S. So that's the new equilibrium prime, equilibrium, and this is the new equilibrium quantity. And as you can see, price went up and quantity also went up. So when the supply increases or the demand increase or decreases or whatever change, when one of them changes, either the supply or demand, we're going to be able to determine what happens to both the new equilibrium price and the new equilibrium quantity. So let's take another one. Now I'm going to say I'm going to change the supply. Let's say that the supply for a product goes down. They no longer produce something. Let's say the supply of milk decreases. Something happens. I don't know what happened. There's a new virus that is killing cows. And cows are dying like there's no tomorrow. So obviously the supply for milk is going to go down. Less milk will be available. Well, what's going to happen to the new equilibrium price and quantity? Well, again, you can do it in your head. You can think about it logically and you say, well, wait a second. If suddenly there's less milk available in the market, what would I expect to see happen to the price of milk? Well, obviously, you would expect that the price of milk will go up, right? And more milk will be sold in the market or less milk will be sold. Well, if there's less milk available, obviously, I would also expect that less milk will be sold in the market. So my expectation is that the new equilibrium price will be higher and the new equilibrium quantity will be lower. But if I don't want to take any chances, what I'm going to do is I'm just going to do a graph. So I'm going to show the old supply and demand curve, and then I'm going to shift the supply to the left and see what happens. So here's how you can do it and not make a mistake. Price, quantity, here's supply, here's demand. And then cows are disappearing. And as a result, the supply of milk goes down. Well, let's shift the supply to the left. That shows a decrease in supply. Remember, for both demand and supply, a shift to the right is an increase, a shift to the left is a decrease. So what happens, we started out with the old equilibrium price and quantity here. And now we have this new equilibrium price and quantity here. And as you can see, immediately you notice that the price went up, but quantity went down. So it's very easy to do this type of problems using graphs, changing supply and changing demand. Now, on a test, it could be that the problem would be as simple as what happens to the new equilibrium price and quantity if demand increases, or if demand decreases, or supply increases, or supply decreases. But it could also say something like this. What's going to happen to the equilibrium price and quantity for cereal if the price of milk goes up? Now you got to think a little bit, and if the price of milk goes up, what's going to be impacted as far as cereal is concerned? And is going to be the demand for cereal. Remember, what changes demand? Changes in preferences, changes in prices of related goods, and milk is related to cereal, and changes in incomes. What changes supply? Changes in the costs of production. So here, when the price of milk goes up, that's going to impact the demand for cereal. And if the price of milk goes up, the demand for cereal is going to go down. How's that transmission mechanism going? Well, when the price of milk goes up, quantity demanded for milk goes down. So the demand for milk does not change. If I change the price, I change the quantity demanded for milk. So as the price of milk went up, quantity demanded for milk went down. But now if people are buying less milk, what they need less of? What they need less of is less cereal. And they will buy less cereal regardless of the price of cereal. So that means that the whole demand for cereal is going to shift to the left. So you're going to have to realize that changes supply and what changes demand. Remember what changes supply and what changes demand. And I may not necessarily tell you that the demand goes up or the demand goes down. You're going to have to realize, oh, if the price of a complement goes up, then the demand for my good is going down. Or another example of a problem where I don't tell you whether the supply changes or the demand changes. It may go something like this. Let's suppose, tell me please, what happens to the equilibrium price and quantity of new housing if the price of lumber goes up? Well, guess what? Now you're going to have to realize that if the price of lumber goes up, that means that there's an increase in the cost of production of new housing. And when there's an increase in the cost of production of new housing, supply of new housing is going to go down. So you're going to have to realize that, oh, okay, supply is going to shift to the left. And then you do your graph, draw the supply and the demand curve, then shift the supply to the left, and then see what happens to the new equilibrium price and quantity. Okay. Now, let's make it just a little bit more complicated. Not a lot more, but just a little bit. So now I'm changing not just supply or just the demand, but I'm changing both supply and demand at the same time. So how many possible combinations are we going to have? Well, guess what? Still 4. There's going to be this. Supply up, demand up, supply down, demand down, supply up, demand down, and the last one, supply down, demand up. Those are all the possible combinations that we can have, so we exhausted them. Now, when you have a problem like this where both supply and demand are shifting at the same time, make a note that in this case, you're not going to be able to determine what's going to happen to the new equilibrium price and new equilibrium quantity. One of those two, either the price or the quantity, will be indeterminate. In other words, we don't know whether it's going to end up higher or lower or stay the same. Okay. So in those type of problems where both supply and demand are shifting at the same time, if you can determine what happens to price, then you know that the quantity will be indeterminate. If you know what happens to quantity, then we know that price will be indeterminate. So you cannot say price goes up, quantity goes down. No. Or price goes up, quantity goes up. No, you can't say that. Okay. If you can tell me the price, then quantity is indeterminate. If you tell me what happens to quantity, price is indeterminate. So one of them has to be indeterminate. So, excuse me. So on a test where you have both supply and demand shifting at the same time, as soon as you see an answer that says price goes up, quantity goes up, you can eliminate it because you know that you cannot determine what happens to both of them at the same time. So how are we going to handle those type of problems? And to handle those type of problems and not make a mistake, for sure, not make a mistake, I would suggest that you do it with 2 separate graphs. So let's take number 1, for example, and I'm going to put up 2 graphs at the same time. Let me erase this So I have a little bit more space. And what I'm going to do is I'm going to in this graph, I'm going to shift just the supply and see what happens to the new equilibrium price and quantity. Because when only one shifts, I can tell what's going to happen to the new equilibrium price and quantity. So let's do supply goes up. So I'm doing number one right now. Supply goes up. Well, supply goes up. I'm going to shift supply to the right. And immediately I notice that price goes down and quantity goes up. And I write down price down, quantity up. Okay, that's what I got from the shift in supply. Now I have to still do the shift in demand. So on a new graph, I'm going to shift the demand. So let's see. Supply, demand, and then demand goes up. So I'm going to shift the demand to the right. That's an increase in demand. Well, what happens to the new equilibrium price? Went up. What happens to the new equilibrium quantity? Also went up. So I write down price goes up, quantity goes up. Now I put them together. So I look at both of them and I see from the supply side, price goes down, quantity goes up. From the shift in demand, price goes up, quantity goes up. Well, guess what? It seems that quantity is pulled up as it goes up from supply and from the demand. But on the other hand, price is pulled in opposite directions. The shift in supply pulls it down, the shift in demand pulls it up. So the price, I don't know where the price is going to end up. The price could end up higher, the price could end up lower, the price could end up the same. So the price is indeterminate. I don't know where it's going, but quantity is definitely going up. So that's going to be the answer. Quantity up, price unknown, price indeterminate. Okay. Let's do one more problem. And well, I want to show you, well, what's going to determine whether the price ends up higher or it ends up lower? It's the relative change between supply and demand. How much the supply goes up, how much the demand goes up. Because obviously if supply goes up a great deal, but demand goes up just a little bit, chances are is that the price is going to end up lower, because it's going to be pulled up a lot more from the supply side than it's pulled up higher from the demand side. So probably price would end up lower. But on the other hand, if we have supply going up just a little bit, but the demand going up a great deal, then probably the price will end up higher. Since the problem doesn't tell you how much the supply goes up and how much the demand goes up, then I don't know where the price is actually going to end up, because it could end up higher or lower. So that's why when it says supply goes up, demand goes up, well, price is actually indeterminate. Let's do one more example. Let's do number 4. Supply goes down, demand goes up. Okay, again, I'm going to use 2 graphs. In one, I changed the supply. In the other one, I changed the demand. So we have the original supply and demand, and then it says supply goes down. So all I have to do is shift the supply to the left. And as you can see, price goes up and quantity goes down. So I write down, price goes up, quantity goes down. Okay. Then I have to shift the demand. So on a different graph, I'm going to shift demand. And in this case, demand goes up. Okay, so I'm going to shift it to the right. Well, notice that the price is actually going up and quantity is also going up. So you write down price goes up, quantity goes up. Now you look at both of them and you notice that price is consistently going up when the supply changes and when the demand changes. So I know where price is going. Price is going to end up higher. But you notice that quantity, when we had a shift in supply, quantity went down. And from the shift in demand, quantity went up. That means that quantity is the one that is going to be indeterminate. I don't know which way will end up. So you say it's indeterminate. Price goes up, quantity indeterminate. So this is a very foolproof way of doing those type of problems, rather than you trying to figure it out in your head. In my head, I would have a hard time figuring out which one is indeterminate and which one goes which way. So very easy. Do those two graphs. You start with the original supply and demand, and then you shift one in one graph, you shift the other one in the other graph, and then you look at which variable is consistently going in one direction and which one is going in opposite directions. Okay. Okay. Questions at this time, because folks, guess what? Chapter 4 is a rather easy chapter. It's a short chapter. So just give it a reading and then watch this video and do the quiz, and you're going to be in great shape. This goes for both macro and microeconomics. This is the last week where macro and micro are identical. Next week, macro is going to cover different chapters from micro, so we're going to start diverging. So next week on Monday, I'm going to have at 10:30 lecture for macro, and at 1 o'clock lecture for micro. Any questions? Because if not, yes.
For macro, for next week, we're doing chapters 5?
No, chapter 6. We're going to skip chapter 5.
Chapter 6. Okay, cool.
Yeah. Okay, let me stop the recording.